Welcome back. This is problem 2b from quiz number 7. And here we're going to again be working with this geometric series, but instead of trying to show that it converges using the geometric series test, we're going to try to show that it converges using the ratio test. So to use the ratio test, we're going to take a limit as n goes to infinity of the absolute value of what? Maybe we should write this down. All right, so remember the big idea of the ratio test is that you want to compare the underlying sequence to something. You don't know what to compare it to, so you compare it to itself, right? But just shift it in one place. So when we use the ratio test, we take the limit as n goes to infinity, the absolute value of the ratio of the n plus first term to the nth term. Okay, you notice normally you write as an plus 1 over an, but man, we always have fractions, and then you got fraction over fraction. What a mess. So let's just use a division sign here. All right, and what we know is that if this ratio, if we call this, say, r, if big R here is less than 1, then the series converges. Okay, and of course, if R is greater than 1, then the series diverges. If R equals 1, then it's sadness, right? The test fails. That's a bummer situation. So let's hope we don't get it equal to 1 in this situation. All right, so to get the n plus first term, that means I need to go out one more step. So this is the nth step. So it would look like minus 3 to the n, but I want to go one more. So n gets replaced by n plus 1. Then I have 4 to the, okay, now if I replace n by n plus 1, I get n plus 1 plus 1, which is n plus 2. Then I'm going to divide by the nth term. Hey, the nth term is already written there for me. Minus 3 to the n over 4 to the n plus 1. All right, now I'm doing a division, but ultimately, right, I'm going to want to flip this fraction, right, multiply by the reciprocal. So let's just get to it. So we have negative 3 to the n plus 1 over 4 to the n plus 2 times 4 to the n plus 1 over negative 3 to the n. And at this point, I'm feeling pretty happy because I'm going to get a whole bunch of cancellation. So first thing I notice, okay, I have n plus 1 copies of negative 3. I have n copies of negative 3 on the bottom. So that's going to cancel all but one of the copies on the top. I'll have a negative 3, and even that negative is going to go away, right? Because we've got absolute values. Then here I have n plus 1 copies of 4 on the top. I have n plus 2 copies of 4 in the denominator. So all but one of them will cancel in the denominator, and I just get a 4 there. Take the absolute value. I'm going to get 3/4. This limit will do nothing. All right? How beautiful is that? I get 3/4, which is less than 1. So by the ratio test, the series n goes from 2 to infinity. Notice that 2 is completely irrelevant when we think about it this way. Of negative 3 to the n over 4 to the n plus 1 converges. Okay. Oftentimes, of course, you end up with some n's, and then you really have to take this limit, right? Thinking about what it actually means, but hey, this is very nice here.